Right, so the next topic we're doing is dividing a line into a ratio, and we're doing this with vectors. We will do it later with straight line, but for now we get vectors for doing it, so that's fine. Right, so what this is we'll get given a line, so say for example the line AB is divided by the point P. Okay? So P divides AB in a ratio of 1 to 2. Okay, so that's the example we're going to do here. Right, so we've got our line AB that we can draw. Again, please use a ruler. I can't very easily on this. Okay, so we've got the line AB, and that could be the vector AB, right? So what we're trying to say is that we've split it in a ratio of 1 to 2. So that tells us that there's a total of 3 parts to this line. To find how many parts there are, you just sum up how many things are in your ratio. Okay, so we've got kind of to split our line into 3 equal bits. And then point P is there. So we can kind of go, there's 3 equal bits. This bit is 1 bit, and this bit is 2 bits. So we've divided it in a ratio of 1 to 2. Okay? We can do this as well with any other ratio. So if we had a ratio of 3 to 5, so instead of a ratio of 1 to 2, so we can call that part A and this part B, 3 to 5. A and B, we've still got, but this time instead of having 3 parts to our line, which we got from our 1 plus 2, we've got 8 bits of our line because we've got 3 plus 5. So this is going to be a bit harder and I'm less likely to get them exactly the right distance apart. So 1, 2, 3, 4, 5, 6. Okay, right. It's fine. 7, 8. Just move B. Okay, if you're doing sketches like that, doing something like that is totally fine, right? It's not any problem. You don't have to try and squeeze them in if it's not going to work. You can just rub it out and move it along. Okay, and this is why kind of when you're doing sketches, it's good to do sketches in pencil if you can. Okay, I know in the exam you have to use a pen, but for now we can use pencil, so it's quite good to do that like in our jotters when we're working things out and using diagrams. Right, so we've got 1, 2, 3 equal bits. So that's where point P is. And then we've got 1, 2, 3, 4, 5. So our ratio we can check is definitely 3, and that's 5. Right, so how does this help us with dividing a line into a ratio? Right, so we'll do it this time and we've got points. So A is the point 4, 6, minus 6, 12. And B is the point 4, 4, minus 3. Okay? And we've got that P divides AB in the ratio of 2 to 3. Okay, so we have our line AB. Again, we're going to have to split it this time into, we've got 2 parts before P and 3 parts after, so that means we've got 5 bits in total. We've got 1, 2, 3, 4, and then we've got 5 bits in between our dots. So that's A, that's B, and this is point P. So we've got 2 before, just to check, and we've got 1, 2, 3 after. Right, so the way this is going to work is it's kind of to do with ratios that we've been doing. We can see that P is 2 jumps out of 5 away from A towards B. So we can say that from A to P is going to be 2 out of 5, 2/5 of the distance from A to B. Because we've got 1, 2, 3, 4, 5, so that's the bottom of our denominator, the bottom of our fraction or the denominator, and we've only gone 2 of them. So the numerator is 2. So it's 2/5 of that full length from A to B, because it's been split into even bits, so we can kind of create fractions from it. Okay, so A to B we need to work out, so we'll work it down here. From our last one, we remember it's B take away A. Okay, so B is 4 minus 3, and A is 4 minus 6, 12. So we get 4 take away 4, which is 0. We get 4 take away minus 6, which is 4 add 6, so that's 10. And then we get minus 3 take away 12, which is minus 15. Yeah? So we have to find 2/5 of 0, 10, minus 15. Right, so when we're finding 2/5 of something, we times by 2, then we divide by 5, or we divide by 5 and then we times by 2. In this case, it's probably easier to divide by 5 and then times by 2, but it doesn't matter. That's how we've been doing fractions since we were in the way lower down the school. Right, so 0 divided by 5 is 0, times that by 2, we still get 0, right? And then 10 divided by 5 is 2, times by 2 is 4. Okay, and then minus 15 divided by 5 is minus 3, times that by 2, we get minus 6. Okay, so we've got A to P. So now we've been asked to find the point P. Okay, so that's what we would be saying. I forgot to write that bit in, but it's fine. So find the coordinate of P. Okay, so we know that AP is equal to P take away A. So rearranging, P is equal to AP plus A. That means AP, which is 0, 4, minus 6, add A, which is 4 minus 6, 12. Right, so we get 0 plus 4, which is 4. We've got 4 plus minus 6, which is minus 2. And then we've got minus 6 plus 12, which is 6. So therefore, P is equal to the coordinate 4 minus 2, 6. Okay, I'll do another example of this, don't worry. Okay, so, right, we're going to have, so we've got the points E and F have coordinates let's go with, they've got coordinates of 3, minus 4, 7, and 24, minus 11, 21. Okay, so the point P cuts the line in the ratio of 4 to 3. What is the coordinate of point P? Okay, most often with these we will see them in 3-dimensional vectors, not 2-dimensional vectors, okay? But again, like we've been doing, there's nothing to worry about with it. Okay, so drawing our line, we've got E to F, right? Because we've got 4 to 3, that means we've got a total of how many bits? 4 plus 3, 7. So we've got 1, 2, 3, 4, 5, 6, 7. Right, 1, 2, 3, 4, 5, 6, 7, just checking. Okay, so we go 1, 2, 3, 4, and that gives us our point P. That's 4, and then we've got 1, 2, 3, so we definitely have that 4 to 3. Okay, so to go from E to P, we're going 4 out of a total 7 steps. Yeah? So it's 4/7 of the distance from E to F. Okay? The diagrams aren't strictly necessary, but to start with anyway, when we're first doing these, they can really help to kind of grasp what it is we're doing and help visualize the steps that we have to take. Okay? And sometimes as well, they can be worth marks. So, because it's showing visually that you understand what it is you're supposed to be doing. Okay? So we need to find E to F. It's always the second one, take away the first one. Okay, so F is 24 minus 11, 21. Take away E, which is 3 minus 4, 7. Okay? So we get 24 take away 3, which is 21. We've got minus 11 take away minus 4, so that's adding 4, which gives us minus 7. And then we've got 21 take away 7, which is 14. Okay, so then EP is 4/7 of 21 minus 7, 14. Again, dividing by 7 times by 4, divide by the bottom times by the top is how we multiply by fractions. So looking at 21, 21 divided by 7 is 3. 3 times 4 is 12. Yep. Minus 7 divided by 7 is minus 1. Times that by 4, we get minus 4. 14 divided by 7 is 2. Times that by 4, we get 8. Right? So we've got E to P as our vector. So we know that E to P can also be written as P take away E, or if we want P on its own, it's E to P plus E. So we've got 12 minus 4, 8, plus E, which was the first point, so that is 3 minus 4, 7. Right, so we've got 12 plus 3, which is 15. We've got minus 4 plus minus 4, which is minus 8. And then we've got 8 plus 7, which is 15. Okay, so therefore, P is the point equal to 15 minus 8, 15. Okay, right, so hopefully that is enough for that. If you've got any other questions or you aren't understanding kind of where this is all coming from, don't hesitate to leave a comment and ask questions or ask in class if you're lucky enough to be in my class. Okay, so that is dividing a line into a ratio, and the next topic we're doing is to do with 3D pathways with vectors, just to give you a little heads up on what's coming next.